Similarity and congruence transformations. A congruence transformation is one in which you keep the same size and shape of the figure, but the position and the orientation change. So where it is and which way it's turned can change, but the size and shape remain the same. Okay? In a similarity transformation, the size will change, but the shape will stay the same. Okay? In a similarity transformation, you can also change the location or even the orientation, but the size and shape stay the same. Okay? So concept one is identifying similarity transformations. When you're looking for whether something is a similarity transformation, right, you're looking for a change in size. Okay? The shape has to be the same, but if the sizes are different, it's going to be a similarity transformation. Okay? When we are looking at similarity transformations, dilation is our number one similarity transformation. So if all your coordinates of the original figure can be multiplied by the same number so that you get the coordinates of the new figure, then the figures are going to be similar, and that number that you're multiplying, that you multiplied the coordinates by, is called the scale factor. Okay? So, a normal question from your book would be, you're given a figure like this, and you're asked if it's a similarity transformation from the green triangle to the red triangle. All right? Now, it is often enough just to look and see that, yes, these do have the same shape, all right, but definitely they are different sizes, okay? But sometimes you won't be given a graph, all right, or sometimes you will be given a graph, but it'll be hard to tell. Maybe the shape looks like, oh, I'm not sure if it's exactly the same. So what you're going to do there is back up to here. You're going to check to see if there's a scale factor. Okay, so if I go to my A is at -3, 3, 6, 9. So my A is -3, 9, and my A prime is -1, 3. Okay, my B is at -3, -3, +3, and my B prime is at -1, 1. Okay, and let's go ahead and stop there. We do want to, if this is the only way we're checking, check on C as well. But let's just look at these two coordinates and the coordinates that line up in the other triangle. And sometimes it's easiest to look and start from your smaller shape and go up to your big shape. Even though this green triangle is my original, because this one's smaller, it's going to be easier for me to see if there's a scale factor going up. Okay? So, is there a number that I would multiply by -1 for A prime, because that's my little triangle, to get -3? Well, yeah, 3. Right? 3 times 3, that's going to be 9, right? Because my scale factor is 3. Okay, so far it looks like 3 works. At least it does for A to A prime, or A prime to A. Okay, go down to B prime. -1 times 3 would be -3. 1 times 3 would be 3. Okay, so for these two coordinates, it does work. We have a scale factor going from the smaller triangle to the larger one of 3. Now, if we're going from the larger triangle down to the smaller triangle, well, basically it's going to be the reciprocal of 3. Okay, it's going to be 1/3. What do I have to multiply by 9 to get 3? Well, 9 times 1/3 is 3. -3 times 1/3 is -1. Okay, you can also think of it as dividing. All right, 9 divided by 3 is 3. Negative 3 divided by 3 is negative 1. Okay, and then the last thing, we do want to check C just to make sure. So this is at 6, 3. And C prime is at 2, 1. And yeah, 2 times 3 is 6. 1 times 3 is 3. So this is a similarity transformation with a scale factor equal to 1/3. Okay? And it's 1/3 because my original figure is the green triangle. It's the larger one. If my original figure is larger, my scale factor is going to be less than 1. It's never going to be negative, but it'll be less than 1. It'll be a fraction or a decimal. Okay? If this was my original, if I had a smaller original figure, then my scale factor is going to be larger than 1. Okay. So now we don't have a graph. We just have the endpoints. All right. So this is a line. It's got 2 endpoints. Let's look at these and let's do the same thing we did up here. See if there's a number that we can multiply by all of my points to get the new coordinate. So I have, and I'll call this A and B. Okay. So A is 1, negative 2. B is 3, 5. A prime, B prime, A prime is 3, negative 2. B prime is 5, 5. Okay, so we start with 1, and that goes to 3. So again, our scale factor could be 3. 1 times 3 is 3. But now we have a negative 2 and a negative 2. So right there, I automatically know my scale factor isn't lining up. It's not going to be a similarity transformation. Okay? It could be a congruence transformation, but it's not going to be a similarity transformation.